Well, welcome everybody to, I don't even remember which edition of CARS workshop this is, Context-Aware Recommender Systems workshop. I guess I don't have to tell this audience why context is important in the context of recommendations and also more generally. There's been lots of work on context-aware recommendation in the past more than 10 years, I would say. In fact, I believe the first CARS workshop was 2010, if I'm not mistaken. So very early in the history of Rex's conference, CARS began, and there's been lots of good work done since then. And of course, the work on context-aware recommendation even predates that by several years. So over the years, there's been work on various notions of context, including, explicit context, implicit or latent context-aware recommender systems, and so on. And this work continues, and we will see some of that work today in this workshop. Let me just briefly introduce all of the organizers. So I'm going to share just the website for the workshop. One second in here. Apologize for the delay for a second. All right. Are you going to see that? All right. So
yes, I can.
Okay. Before talking about the program, actually, here are organizers. You can see most of us online right now. Actually, all of us. So get us. Konstantin, myself, Francesco, Alex, and Moshe, and special thanks to Moshe and Konstantin for doing a lot of the organizing and background work on this workshop for the past several years. So we are happy to continue working on this workshop. We have a good program today. So the program contains, we have two keynote speakers. I'll introduce Lucas in just a couple of minutes as our industry keynotes, and we'll have another good keynote talk later in the afternoon. So the keynotes sort of bookend our program, the rest of our program. You can find the program at carsworkshop.com/program if you like to take a look and look at some of the details. But after the opening, we're going to have Lucas's talk, then take a short break. Then we'll have a couple of the paper presentations, followed by another break, short break, and two more presentations, so a total of 4 papers. And then after the last break, we will have the last talk by Anand Day, who's also done work on idea of context for quite a long time in computing in general, not just in recommender systems. Okay. Anybody else, any of the other organizers like to add something before we get started with the keynote address?
I just want to point out that in addition to whatever Bamshad said, the presentations and the papers are online in our website. You can find it in the program and also in the accepted paper section.
Thank you. And of course, the session is being recorded, so it'll be available, I assume, at some point later for people who want to watch it. Okay, so it's my pleasure now to introduce our industry keynotes. Lucas Maystre from Spotify. Lucas is a research scientist at Spotify, has been working on improving users' long-term engagement and satisfaction. He's done a lot of work on probabilistic models for machine learning, developing effective models or computationally efficient inference algorithms. He got his PhD at EPFL, and his work was supported by Google Fellowship in Machine Learning. So we are all looking forward to hearing from Lucas. Lucas, are you ready to begin?
Yes, let me...
I will stop sharing. And by the way, before you start, if people have questions, please post it on the chat. You can also, of course, ask yourself during the Q&A session in person if you prefer it that way, or do both. So, thank you.
Thank you. So yes, hello everyone. It's really a pleasure to be giving this this keynote today. My name is Lucas. I'm working with Spotify. I'm based in London. And today I'll tell you a little bit about some work we've done on different aspects of context-aware recommendations. And before I start, I'd like to thank the organizers for inviting me, especially Moshe and Konstantin, who have been coordinating everything. So thank you very much. All right, so I'm part of a team of about 30 researchers who are embedded within this broader organization at Spotify called Personalization. And the mission of that organization is to match fans and creators in a personal and relevant way. And so we own a number of features and surfaces. Among others, there's the homepage of Spotify. So when you open the app, there's basically a screen that shows you a number of little cards that are personalized and contextualized. We also have a number of playlists that are personalized. So the goal there is to rank tracks based on your preferences and based on a number of other signals among a pool of candidates. And then also the search engine. So those are kind of some of the products that Personalization is working on. And if I try to think of, some of the challenges that are perhaps, a little bit not straightforward if you think about recommender systems. So some of the things we spend a lot of time thinking about that are perhaps non-trivial. One is that Spotify increasingly is going beyond music and is also trying to, become a service where you can listen to any type of audio. And so we're investing a lot in podcasts, for example. So we have to deal with these different types of content. Also, if you look at the mission statement, there's kind of an emphasis on both sides, right? There's the users, and we want to be as relevant as possible for the users, but then we also want to make sure creators get the exposure they deserve. And so that's, I think, an area where there's a number of very interesting challenges, really thinking about the two sides of that marketplace. And finally, and I'll get back to this at some point in the talk as well, there's kind of increasingly a shift from really short-term notions of success, like, trying to measure how much users are complying with the recommendations we give them, towards kind of a more long-term view of user satisfaction. And so that kind of opens the door to a whole new set of research problems, and how can you think about optimizing for the long term. So just for some backgrounds, Spotify, like a few numbers, there's 165 million subscribers. So those are users that pay a monthly subscription and that get access to unlimited on-demand music. And then there's altogether 365 million monthly active users. So the rest of the users have access to the free tier, which doesn't give you kind of on-demand access. You can kind of choose, a radio station, or let's say a kind of music you're interested in, and there are ads, but in exchange you don't have to pay anything. And as you can see also, especially in recent years, we've really expanded in many markets, which also comes with some really interesting challenges in terms of making things relevant across many different markets and cultures. So one of the reasons I also show this is because scalability is often a challenge, and actually, even in research, we often try to have engineering considerations in mind, because those are really very important in getting to a successful application of research projects. Okay, so with this, I decided to structure today's presentation in two parts. So the first part will be about perhaps a more traditional concept of context-aware personalization, where the goal is really to improve somehow immediate relevance by taking advantage of contextual information. And then in the second part, I want to somehow talk a little bit about context-aware personalization in the setting of, trying to go beyond immediate clicks and things like that, and try to think more about recommendations as a sequence of interactions with the user, where you don't want to necessarily, think about what you're doing exactly at a given moment, like one shot, but more as a sequence of interactions with the user. And I think in that case, context can also play a big role in terms of identifying perhaps opportunities to improve long-term satisfaction. So I'll start with really this perhaps more traditional notion of context awareness, and we're going to look at two projects that we've been working on at Spotify. The first one is really kind of a classical problem where we have explicit context that we observe and want to use it to perhaps anticipate better what a user is going to do during a session. And then I'll talk about a second project where context plays a very important role, but it's not directly observable. It's latent, and by modeling it still, in a principled way, we can drastically improve downstream performance in terms of the task we're actually interested in. So first project, the question we're trying to ask here is, can we use context as a way to better predict the music a user will stream during a session? So the setting is, we have Spotify's homepage, and imagine the user just opens the app, and we want to anticipate as well as possible what they're going to stream during that session. So inputs are, the usual stuff like static preferences, what we know about the user's preferences, maybe information about recent sessions. And then on top of this, we add two pieces of contextual information: the device that they're using, whether it's their phone or the desktop app or the web app, and the time of the day, whether it's morning, afternoon, or evening. And then we try to predict basically the music they're streaming during the session. So this is a work that was presented at Rexis last year, led by an intern that worked at Spotify in summer of 2019, that I'm going to present here. Okay, so first, some exploratory data analysis. So we have these two contexts that we're interested in: the time of the day and the device. And so we wanted to look a little bit whether there was, an opportunity to use this as a way to improve our predictions of what users are going to do at the beginning of a session. We have this data set with where we look at users' sessions over a 2-month period, I think it was, for a sample of 200,000 subscribers to Spotify. And we can just plot the histogram of different contexts that we encounter in this data. And we see that for time, there's reasonable contexts are represented, across the different options that are there. A little bit less heterogeneity for device. But okay, so that's just, kind of at a high level, like marginal statistics about how contexts are represented in the sessions data set. But then we also decided to look at for a given user, maybe a given user is always using Spotify in the afternoon. That's just maybe their habit. So maybe if you think about a given user, it doesn't really make sense to look at context. But actually what we observed is that most users encounter multiple contexts within the window of data that we had, which was 2 months. And that was extremely the case for time, and maybe a little bit less for device, but still, even for device, given the imbalance that we see above, it's quite striking to see that most users encounter multiple contexts. So that's kind of a motivation for looking into these variables. Now, the other thing that we need, of course, is that differences in context somehow predict or correlate with differences in content, right? In kind of the content of the session that happens. And so, yeah, I'm not going to go into the details of the plots below, but basically we were able to convince ourselves that even controlling for differences across users, because of course some users are going to listen to some type of music and prefer perhaps some times of the day or some devices, but even controlling for all of these things, we can observe a very kind of reasonably strong correlation between the context and the content of the session. So that kind of indicates that there might really be an opportunity for predictive models to leverage that context to improve predictions of what a user is going to stream in a session. So before I jump into a description of the model and the results, let me do a quick detour and tell you a little bit of how we think about music similarity at Spotify. And so this is really one of the core, let's say, abstractions that we use throughout many of our personalization features. So we have these track embedding vectors that encode some similarity between, some notion of similarity between tracks. And it's learned using some variant of collaborative filtering. So the way we learn these vectors is that we take user-created playlists, and the signal that we use to train these vectors is that we try to push the similarity towards 1 when 2 tracks are likely to co-occur within a playlist, and we try to somehow push the similarity down when tracks are unlikely to co-occur. So we typically sample negatives to somehow, yeah, get the 2 types of signals in the training data. And so the takeaway from this is that from these user playlists, we can learn this 40-dimensional vector space where every track is a point in that space, and distance in that space essentially captures musical similarity. So, okay, so now let me describe the predictive model that we came up with. So again, to recap, the goal is at the beginning of the session, we want to predict tracks that will be played during the session. So we assume we have access to all the information that would normally be available to us at the beginning of the session, which is, static preferences, recent sessions, and then time of day and device used for that session. And perhaps what's interesting in this model, and what I want to draw your attention to here, is that this model outputs actually a point in that track embedding space. So there could be many different ways of modeling that problem. I guess a common one would be to see it as some kind of giant multi-class classification problem and output somehow a probability vector over tracks ordered by how likely they are to occur within the session. What we do here actually is that we reuse this existing track embedding space, and our model outputs a point in that space with the assumption that tracks within the session are going to somehow be in that corner of the space. So the way we train the model is by maximizing the cosine similarity or minimizing the cosine distance from the predicted point in that space to the tracks played during the session. So again, I'm not going to go into the specifics of the model. It's a recurrent model that uses a number of clever insights to try to combine, these various inputs in the best possible way. But really, maybe the interesting bit here, I think, is really how we chose to model the output and represent somehow the prediction as a point in that track embedding space. And we measure the performance of this model on two tasks, two downstream tasks. One is try to discriminate the next session from further sessions in the future. And another is to try to predict which tracks are going to be in that session. So it's basically two types of ranking tasks. And we consider a number of baselines, some really simple straw men that look at recent sessions or things like that, as well as more complex and sophisticated state-of-the-art sequential models. And it would take a lot of time to go into the results and details, but I just wanted to I guess, highlight two things. One is that we do observe improvements in predictive accuracy by using context and by using the specific architecture of the model we developed. But what struck us particularly, and I think what made us quite happy as well, is that it seems that the improvement, if you break it down by session context, is particularly large in contexts that represent a minority of the data. So it seems that when there is something special, that's when our context-aware model is particularly, gives a kind of has a particular edge over, let's say, more traditional approaches. For this project, really, the takeaways is one, context really seems to matter. So without even looking at the specific model we used, I hope I convinced you that there was evidence that contextual information, in this case, time of day and device, correlates with the music that people stream in a session. And then, of course, that's kind of an opportunity for particular recommender systems to try to leverage this and improve relevance of the output that they produce. And the second aspect, and this is maybe one interesting takeaway from an industry perspective, is I guess one of the challenges of context-aware recommender systems is that to some extent, they really need to make predictions in real time, because the output depends on the timely signal that is perhaps available only at the moment where you want to display results. And so that raises a certain number of engineering challenges. And there are two ways in which we tried to make it as simple and easy as possible here. One is to really rely on this existing shared representation, which we took as kind of a common language across personalization systems. So that makes it really easy to interface with other services and features. And the other thing is, the more you can pre-compute, the better. And the more you can, avoid making costly model inferences as serving time, the better. And so in this case, because we have these discrete contexts, we could potentially pre-compute a small number of predictions for every user based on, what we think the contexts they will encounter will be. And pre-compute all this, and at serving time, just use a lookup table or something like that to really make it as efficient and simple as possible. So that was for an example where context is observed, and we really, take it as an explicit input into the model. But there are cases where context is very important, but is not necessarily observed. And this is the case in in this work that was authored by some of my colleagues and presented at KDD earlier this summer. So the question they asked is, does modeling context help discriminate between music and podcast search queries? So the context here is, or the setting is search on Spotify. And a few words about our search engine, some characteristics. So its results are instantaneous. So it's kind of a search as you type system where, as users add in characters, the ranking kind of changes and gets really displayed as they type. There's heterogeneity. So this is really the part that's going to interest us here. Users may be searching either for music or for podcasts. And obviously, this is going to have a huge impact on what results are relevant and which ones we want to surface. And then there's also challenges around multi-representation. So it's not only about matching the text of the query to, you know, some text describing the content. There's like much more complex representation of contexts and queries that we need to use. But I'm not going to talk about this much today. So really what I'm going to focus on here is this idea that there's a latent context, which is whether the user's intent is to find music or podcast. And this is like explicitly modeling this is going to help us a lot. Again, some exploratory data analysis to convince us that, you know, behavior is a bit different when you search for music or podcast. Users seem to put in more effort when they search for podcasts. So the average query is longer as measured by the number of characters, and they are more likely to refine it and delete characters and kind of, yeah, rewrite their query multiple times. Also, the way results are consumed once the search query is issued is different. So what struck me is that it seems that users, when they search for podcasts, they typically, they're more likely to save it for later than when they search for music. So either download it or add it to a collection. So with this in mind, so that really the key goal of this project was to you know, rank the results as well as possible, putting the most relevant results first for a given query. But knowing that there's this latent context that strongly influences the relevance, my colleagues decided to explicitly model search intent. So the way they did this is by setting up a multitask model with two losses. There's the traditional ranking loss on the left. And then there's also a binary loss on the query intent, which is basically a prediction, is the user searching for podcasts or music? And the way the label is determined there is just looking at the item that gets clicked in the end and looking up whether it was a podcast or music. And so what's interesting is that at the end of the day, all we care about is really the ranking, but explicitly adding this identification loss helps the model rank results substantially. And so I just highlighted one of the metrics they capture in an ablation study where they look at the performance of the model with and without this query intent type identification. And with the full model, performance increases substantially. So takeaways here is really that beyond context that we can observe, there is also latent context that plays an important role, and explicitly modeling that latent context can help the task we really care about here, which is, in this case, ranking search results. So yeah, that's it for the first part, which was looking once again at this more short-term notion of relevance and using context for that. Now, there's really this increasing shift towards viewing recommendations through, you know, the lens of really a sequence of interactions with the user. And it's really kind of grappling with things like delayed consequences and intertemporal trade-offs and with the goal of really improving long-term satisfaction. So not necessarily session level metrics like how long did the user stream, but really trying to think, is the user going to remain a subscriber perhaps 6 months from now or 1 year from now? That's one of the ideas we could have for expressing long-term satisfaction. And I guess the idea here is that I think that there's a lot of the literature and context-aware recommender systems that could, I think, play a role in kind of shaping this and improving these aspects as well. And so there's kind of a broad notion of context that we could consider as the state, like at what stage of a journey is the user, what's kind of the history of interactions the user did so far, and we can really use that state to perhaps not only improve relevance, but also maybe identify what are good moments to improve maybe long-term goals we have for kind of a long horizon in a sense. And so I'd say this is really a topic that we're investing in a lot and that we're spending a lot of time thinking about. I feel we're still relatively at the beginning of this, but I'm going to highlight one thread of research that goes a little bit in that direction around diversifying users' preferences. And so the research that kind of spawned this was more of an observational study of how users' consumption diversity relates to their long-term satisfaction. And this is a paper we presented last year at the World Wide Web conference. So the idea is that if you think back about the track embedding model that I talked about a couple of slides ago, we have this space of music in a sense, and we can represent every user by the point cloud of the tracks they listen to, right? So the idea is that some users are like user A, and the tracks they listen to are somehow spread out in that space. They might listen to classical music as well as, I don't know, electronical dance music and jazz or something. And then there are users that are more like user B that might, stream just as much, but perhaps in a much narrower region of the space and listen just to, maybe a few related artists or kind of a very specific genre and just stick to that genre. And so to measure this, we devised this metric called the generalist specialist score, which builds on top of this track embedding space. So the idea is really very simple. You start from this track embedding space, you represent every user as a point cloud by taking every track they streamed in the past, say, the past month, perhaps weighted by number of times they streamed it. And you compute somehow the volume that this point cloud takes. And so you can make this formal, with some formulas, but really the idea is this, is like how voluminous is this point cloud that captures users' consumption. So a user that has a diverse listening and has tracks all over that space, we would say that this user is a generalist, and then a user that has a much more concentrated consumption around kind of a narrow region of the space would be called a specialist. So we can compute this metric for every user on Spotify. And with this score, we can then ask questions like, how does, where you are on this generalist specialist spectrum relate with long-term outcomes? So one thing we looked at is retention. So we took a sample of subscribers and we computed the GS score for these subscribers sometime in 2018, let's say July 2018. Then we look 1 year later, July 2019, are they still subscribers or not? And we just plot the correlation between their GS score in 2018 and whether they are still a subscriber or not in 2019. So in this plot, we normalize everything with respect to the average churn rate. So higher churn means kind of a worse outcome, means that people are leaving. Lower churn means people are staying. The x-axis here is the GS score. So on the left is like more diverse users, on the right, less diverse users. And what we observe is that there's really kind of a strong correlation between GS score and churn rate in a sense. And so at the extreme, between extreme generalists and extreme specialists, there's almost like a 25 percentage points difference in churn, which is obviously kind of a huge numbers in terms of business impact, if you think about it. So in this plot, we're showing this for different activity buckets, because obviously there's a concern that maybe activity is confounding our diversity metric as well. But it turns out that for various levels of activity, so overall engagement, there's really a strong difference between generalists and specialists. And perhaps what's even more striking is that this difference, actually diversity is a better predictor of churn than activity, which is something that really struck us and that we thought was remarkable. So we did a similar analysis with conversion. So those are users in the free service. And we look at whether 1 year afterwards they convert to premium or not. And the story is kind of similar. So the more generalist you are, the more likely you are to convert, within a year. And this holds again across activity buckets. And there's again a kind of a very strong difference between extreme generalists and extreme specialists. So controlling for activity, more diverse users are more likely to become subscribers. So takeaways really here is that high diversity is associated with really positive long-term outcomes as measured by conversion and retention. So of course, the million-dollar question is like, is this kind of a causal relationship? Is it true that if we were to somehow introduce users to new genres, they are more likely to convert or more likely to retain? Or is it just, all due to some higher love of music or something like that? And this is a question that we're really investigating and spending quite a bit of efforts, because it's an important one. But probably the question is like, there's part of it that's causal. So assume for a moment, and for the sake of this presentation, assume that, part of this link is causal. Like diversity does increase your long-term satisfaction. How would we go about diversifying users' consumption? One way would be to just, inject random tracks, but I think we can all agree that this is unlikely to work. So how do we do it in a meaningful and clever way? So this is the question I'm going to look at in one slide. But before I move on there, I just wanted to highlight that there's a paper at this year's Rexis by some people from Google that look at something very similar. So they also look at somehow long-term satisfaction, and so they look at it in the context of a reinforcement learning system. And they kind of think about diversity in terms of exploration and so on, but they have somehow insights that are really quite well aligned with our findings. And it seems that things like what they call serendipity, which is kind of our diversity, seem to be extremely important for long-term satisfaction of users. So, all right. So the next stage is really, okay, given this finding, how do we go about progressively introducing users to perhaps a new region of that music space? And the picture we had in mind here is, think of music space as like a collection of little islands. And perhaps a user is on one of these islands, say pop, And then the question is, can we somehow map out the best way to bring a user from pop to jazz? And so maybe there's kind of a series of gradual steps that we can take to bring the user progressively there. And so in this case, there's a notion of, where is the user along that journey, and can we somehow think ahead and somehow map out such a plan. So this is something we explore in a paper that we presented at this year's WWW. So the data we use in this case, in terms of describing music, we use a slightly different description. So we're no longer in that track embedding world, but instead we use a collection of microgenres. So those are a little over 4,000 labels that describe like very fine-grained musical genres. And then we have this data set of 100,000 subscribers, and we describe every user as a time series of vectors. So at each point in time, a user is described by a 4,000 dimensional vector, which describes how they allocate their streams across these 4,000 different microgenres. We have these time series for every user. And yeah, every step corresponds to 3 months, so a quarter. And we look at really 4 years of data. So it's very kind of at a very large temporal scale. And what we want to learn is whether there is some regularities in how users somehow shift from one genre to another. And we proposed this very simple model, which we call the preference transition model, which is essentially some kind of first order Markov chain model. So we try to predict what a user is going to stream in the next month by multiplying somehow a vector that describes their consumption on the previous month by a transition matrix. And so the parameters in our model are this transition matrix A that tells you how much listening to genre I somehow predicts that you will listen to genre J at the next time point, so the next 3 months. So the nice thing about this model is that it's pretty easy to train, and the parameters are highly interpretable. So we have this matrix and we can really understand what each entry in this matrix means. And we can reinterpret this matrix as the adjacency matrix of a directed graph. And with this, we can somehow construct this graph that tells you how to reach, how to go from one genre to any other genre by taking somehow manageable small steps. And the idea is that we can use this really as a map to progressively bring users, say, from classical to modern blues in a progressive way. So yeah, takeaways here is that there's really consistent patterns that we can mine from longitudinal consumption traces, and by learning these patterns, we could potentially introduce users to new genres in a kind of a gradual and meaningful way. And so here, really the setting is that we think of context as a notion of state. Where's the user along that journey? And we're somehow planning recommendations over many interactions. And with this, it's time for me to conclude. So just to recap, in the first part of the presentation, I talked about this more maybe traditional notion of context for short-term relevance. And I hope I convinced you that there's evidence that both observed and latent context help predict user needs. And I also briefly mentioned engineering challenges and how to overcome them pragmatically. And then in the second part, I kind of shift gears a little bit, and in the context of this increasing shift towards sequential viewpoint and long-term goals, I think there is really an opportunity for ideas from context-aware recommender systems to improve somehow how we approach recommendations for the long term, by identifying opportunities to improving long-term satisfaction and planning decisions over multiple interactions. And I feel this part is really, it's scratching the surface, and I think there's a lot more to come there. So yeah, with that, I'd like to thank you for your attention, and I'm happy to take some questions.
All right, thank you very much, Lucas, for an interesting talk. If you have questions, you can raise your hand on Zoom, or you can type in the chat if you like. So I see already Francesco has raised his hand, so go ahead, Francesco.
Okay, thank you. Thank you, Lucas. Very, very interesting talk. Thank you for being very, very clear. But I have a lot of questions, but I will just keep it short, just a few of them. First of all is on the first paper where you talk about, let's say, this context, which is the time and the device. But then you talk about this embedding on this four-dimensional space, which is related to the, let's say, co-occurrence. So in our understanding, this type of embeddings are representing the context which is implicit in this, let's say, co-occurrence relationships. So I would also imagine that this is representing this hidden context, which is not clear. They've clearly defined let's say, the time and the device. But have you tried to understand the meaning of certain dimension? Because I imagine it could be related to this implicit context. This is the first question that I have.
Yeah, I see. So you're okay. That's a very interesting question. Yeah, we didn't really look into this, like basically trying to interpret, perhaps instead of fixing context up front as being time of day and device, looking at whether they're like dimensions of these this 40-dimensional embedding that might explain some latent things. That's so the way we viewed this this embedding was more kind of as a pragmatic way to express something in terms of music content, not as a way to really mine context. But yeah, I think that's definitely interesting.
If I can add the second question, very, very quick question. It's about this the other paper that you presented about this retention and the diversity, the experts and now the specialist and the generalist. I'm not that sure that this is related with diversity. Now, I don't know, that just a guess. Obviously, let's say specialists are just listening to one type of music. Don't you think that could also be related to the fact that the type of usage of the platform for this type of specialists is very, very limited, so that competitors can capture this type of users, but they are not exploiting really the platform like the generalists, which are maybe using the platform in more and more sophisticated way, so then they stay in the platform for that reason. So it's a matter more related with the type of the usage of the platform, the functionality of the platform that obviously is correlated with the diversity, but I don't know whether it's really the diversity that matters. I don't know whether it's clear, my question.
Yes, no, it's very clear. And I think, yeah, you're spot on. I think there's really a lot, and I think this is really the interesting bit about this work, is that there's kind of a huge correlation, and it's really striking, I think. But then it really raises the question, like, how do you explain this? And I guess to some extent you are right. I think it's true. Like probably people who have this more who are more diverse, it's maybe a sign just that they find more value across multiple parts of the platform. I really, I had to go pretty fast, and we're looking into some more interesting things in the paper. In particular, one thing that maybe might be, interesting, I think, in this discussion is that one thing that we observed is that recommendations on Spotify seem to serve specialists better. So when you have this very narrow preferences, then I don't know, we can understand them more easily, and somehow, our recommendations are more spot on, and somehow generalists, we have kind of a harder time serving them well. And so maybe one of the questions that comes out of this is like, is there something we can do? Because it seems that the generalists are those that really, have a high value, and that we might need to somehow cater to better in a way. So there's a whole aspect of the interplay between, this metric and what it says about the user and algorithmic recommendations that I didn't go into too much, but that
Thank you.
Kind of is very interesting to study in itself as well.
Thank you.
So there is also other questions. In fact, this was one of my own questions, kind of piggybacking on Francesco's, about the causality versus correlation of the what you call the GS score, and and the willingness to explore and so on. And one of the things, and Francesco touched on this, is that maybe the type of user is different, right? So perhaps they need different metric for satisfaction. So if you're trying to measure the, so a user maybe that's very focused on one type of music, perhaps has a different goal when they're listening to your platform than a user that uses it as kind of a way to explore, right? So different types of users, but the satisfaction for those two users perhaps should be measured differently, not necessarily in terms of how long they are engaged with the platform. In some ways, that focused user may actually satisfy their needs much more quickly, for example, than somebody who just is interested in long-term exploration. So interesting question. I don't know if you wanted to add any more to that.
Yes, absolutely. Yeah. So I hope I was careful to say that, this is, we found associations, right? But for sure, the question of, what is exactly the causal effect here is still open. I mean, I cannot share too much, but one thing I can say is that I think we're pretty convinced that at least part of it seems to be causal. Like maybe not the whole effect is, maybe there's some confounding going on. And indeed, retention for generalists might not mean the same thing as for specialists. And so might be explained in other ways as well. But it seems to be that if we can bring users to start, I guess more broadly than just musical genres or different parts of the musical space, I guess it goes back to bringing users to find value in not just maybe one narrow part of the app, but kind of other things as well. It's somehow a good way to make them, happy over many months.
Thanks. Alex.
Yes, somehow Francesco asked all the right questions. So Bamshad has the question related to the second question, and I have the question related to the first question which Francesco asked. So great minds think alike, Francesco. My question is, so you had this latent representation of music, this 40-dimensional vector, and you have explicit representation of context, device, and time. And then in your diagram, you feed them into the LSTM model. And so clearly somehow you combine the explicit and latent representation. And you went a little, correct. You went a little bit quickly over it. My question is, can you talk a bit more about this process of combining explicit context with latent representation, basically latent versus explicit, and combining the two?
Well, so
because there are lots of issues there, right?
Mm-hmm. So in a way, in our model, everything is explicit. So you're correct that I guess one way we could train this model is to, have this explicit context and then jointly learn the representation of tracks and the, I guess, and the kind of the task we're interested in, which is predicting what's going to be in a session. But in this, in our case, we actually use this existing 40-dimensional embedding, which indeed is, learned through another model and with some kind of implicit signal. But in our model, it's in a way, everything is explicit, what gets into it. These embeddings don't get trained further. So the way they get combined is basically, you have a context. In our case, are these discrete bits of information, right? So which time of the day it is. So it's just kind of encoded as a one hot vector and concatenated to say, the embedding of the previous session. And then this is all, fed into a neural network that then somehow learns to pick up the patterns that somehow help predict the output.
Right.
But this is maybe something I want to emphasize, and I think this is kind of this is something that I kind of learned to appreciate also at Spotify and in industry. We found it important to somehow stick to this existing embedding space that is learned independently and maybe with a different data set, and then use this kind of as a given and as a space to operate in for our contextual model.
We are almost out of time, I think, but there's one question on the chat. Maybe you can quickly address, or a couple of them. Did you try other contextual features other than the time and device in terms of the explicit features when you were using this model?
Yeah. So, okay, we didn't try a whole lot, but one that I can briefly talk about and that I think is interesting is we thought, what if in addition to knowing the time of the day and the device, we know which feature of the app you're going to use. So is it going to be, a playlist? Is it going to be still kind of at a high level? So of course, we don't know which playlist or anything like that, but kind of which feature of the app, kind of keeping in mind, like with the idea that maybe, it's not at the moment the user opens the app, but maybe when they click on the feature that we can make a prediction. And this kind of really substantially increases the accuracy of the prediction. So there's even more signal in if we know where in the app the user is going to go. So this is one thing we looked into.
Okay, thank you very much, Lucas. Excellent talk.
Thank you.
So good work. And we do have, there might be another question or two on the chat. If you feel free to respond to it on the chat if you like. We have a break until for 10 minutes, I guess. Then we're going to start with the next session.